IP and destination modem, I leave it. Now if you see these two packet, this packet and this packet, these two packet look alike. When there are about 100 connectivity going out and 100 replies comes, if all the 100 replies are look alike, the firewall will be confused as to whom the packet should be distributed, given to. So what happened, 30.10, 20.1, 2080, the packet is similarly, even if you map the source IP address here 1050, and here also it is 1050. If you map this source IP address, if you map the source IP address, but still the packet will look alike. Here it is 1050 and here it is 1050. What happens, these two packets will look alike. Even if you map the source IP, still the problem is there. In order to overcome this particular problem, what Checkpoint Firewall does is it changes the port number from 10,000 to 60,000 ranges. I remove all this. See, it says 10,001 and it changes like this. Whatever the source port number here, after the translation it changes the port number from 10,000 to 60,000. 10,001 till 60. It's not that 10,001, 2, 3, 4 it should come like that. In any order it can come. 10,001, and when this particular packet comes, it will be 10,001. And the second packet, the 10.20, also wanted to access the same thing. When the 10.20 wanted to access, say for example 10,002 will be the port number, 10,002 will be the port number, and the reply will have 10,002 port number. So now if you see this particular packet and this particular packet, there is a clear distinction that 10,001 is the port number. This has to be translated to 10.1 because this IP address will be mapped here in the NAT table. This is known as network address translation table. In the NAT table, the IP address and this particular port number is mapped together, so that now it is easy. 10,001 to this particular system, 10,002 to this particular system, 10,003, 4, 5, 6, 7, 8, all the packet can be distributed or given back to the system who has requested the connectivity. This is what basically how the network address translation is taking place in the the firewall. We'll configure this and find out exactly what's happening behind the scene. I minimize this. I say double click on the dashboard and I give the password. I say OK. This is the firewall. So it's any drop. That's the basic thing. What we should, we go to the NAT tab. There is nothing. No rule is written here. So what we should do is we have to create a network object here. This is say my LAN. A network address is 10.0.0.0 and the mask is 255.0.0.0. I go to the network address, I put a tick mark here, I select the hide mode NAT, I say OK. When will I select hide mode NAT? I minimize this, I go to the diagrams. So the NAT BMP is there. See, whenever there is a client inside and the server is there out in the internet, we provide something known as hide mode NAT. Or hide mode NAT is provided in the firewall when the client is there inside and the server is there outside. I minimize this, and now you see the firewall. Close this. The firewall, I created a network object and right click and edit it. We provided hide mode NAT because our client 10.10 is there inside and the server we are going to access is there in the internet. Okay. Now any source any destination should not be, it's not a good practice, but let us say any source any destination and you say accept and you can log it also. Any source any destination, you can say even 10.10 and you can create a node and